different methods of water application on farms. Now, irrigation. What is irrigation? Irrigation may be defined as the science of artificial application of water to the land in accordance with the crop requirements throughout the crop period for full-fledged nourishment of the crops. So as I said before, that the natural way to supply water to the crops, that is rainfall. But since rainfall is variable and plants require certain amount of water at fixed intervals, so it's very difficult that these conditions are fulfilled by natural rainfall. So consequently, we have to artificially supply the water to crops during the crop period. So irrigation is the science of application, artificial application of water to the land in accordance with the crop requirements throughout the crop period for full-fledged nourishment of the crops. So it means that we have to artificially supply the water in accordance with the crop requirements. When the crop need water, so we have to supply the water, and this will continue throughout the crop period. So this is irrigation. Irrigation is the art of supplying water to the land by artificial means to fulfill the water requirements of crops in areas where rainfall is insufficient. So where rainfall is not sufficient to fully meet the crop water requirements, we have to artificially supply water to the land to fulfill the water requirements of crops. Another definition is irrigation may be defined as the process of artificially supplying water to soil for raising crops. Irrigation is artificial application of water on an agricultural land for the assured growth of plant life. So you can see that all definitions, the summary is that irrigation is the artificial application of water during the crop period to fulfill the crop water requirements. What is irrigation engineering? The science of planning and designing a water supply system to the plants, crops for their normal growth during the period of no rainfall with the help of dam, weir, barrage, reservoir and canal system with headworks, cross drainage works and miscellaneous works of canal like canal falls is called irrigation engineering. So irrigation engineering is the science of planning and designing of a water supply system to the crops, to the agriculture land, and that include all the hydraulic structures. You can see that with the help of dam, weir, barrage, reservoir and the canal system with headworks, cross drainage works, which we discussed that if we construct a canal and it has to carry water and it crosses a natural drain or stream, so how it has to cross? Should the canal be taken above the drain in case of aqueduct or below in case of siphon? So these are known as cross drainage works, and miscellaneous works of canal like canal falls. When there is a drop in elevation of the natural ground surface, so there we have to provide canal falls. This is known as irrigation engineering. We have to artificially supply the water to the crops for their growth during the crop period. This is irrigation. Then irrigation engineering is how we supply this water to the crops. The different hydraulic structures, the canal network that we have to construct to supply water to the agricultural land, that is irrigation engineering. Irrigation engineering is the analysis and design of systems that optimally supply the right amount of water to the soil at the right time to meet the needs of the plant system. So irrigation engineering is the analysis and design of the system that optimally supply the right amount of water to the soil at the right time to meet the needs of the plant system. Irrigation engineer. An irrigation engineer is the one who helps to bring irrigation water from the source of supply to an agricultural land. So irrigation engineer is the one who helps to bring this water from the source to the agriculture field, to the agricultural land. That is irrigation engineer. Now, is artificial application of water to the crops for their growth, is it a new science or art, or this is in practice since the beginning of the human civilization? So here we briefly discuss the history of irrigation. Irrigation system is as old as human civilization. In fact, civilization would probably not be possible without some form of irrigation. Because in irrigation, we artificially supply water to the crops for their growth, and these crops provide food which is necessary for human survival. So that is why civilization would probably not be possible without some form of irrigation. The earliest form of irrigation probably involved people carrying buckets of water from wells or rivers to pour on their crops. So in the beginning, probably people used buckets to take water from the well or river and pour on their crops. Ancient Rome built structures called aqueducts to carry water from snow melts in the Alps mountains to cities and towns in the valleys below. This water was used for drinking, washing, and irrigation. So Roman aqueducts, these are very famous, that how they take the water, that is the water from snow melt in the Alps to cities and towns in the valleys below. So they use these aqueducts to carry the water, and this water was used for drinking, washing, and irrigation purposes. So aqueduct is actually a channel that carries water across a depression. So you can see that ancient Rome, they built aqueducts to supply water to agricultural lands in addition to using the same water for drinking and other purposes. The Chinese are known to have practiced irrigation since 2600 BC. The earliest work in China relate to the development of the delta lands and the Yellow River. The 1130-kilometer long Imperial Canal, also called the Grand Canal, built in 700 AD for irrigation and navigation, is one of the greatest ancient irrigation works. Diversion of irrigation works were developed in Iran in about 500 BC. A system of canals, tunnels, tapping groundwater from recharge areas of surrounding mountains and leading it by gravity to the fields to be irrigated is still used in Iran as it was practiced 2500 years ago. So you can see here that in Iran since 2500 years, they have this system of canals, tunnels that tap the groundwater from recharge areas of surrounding mountains, and then the water flows by gravity to the fields that are to be irrigated. Diversion of streams by canals for irrigation was practiced in Japan before 600 BC. Irrigation by diversion works and direct flooding by rivers is known to have extensively practices in Thailand, Philippines, and Indonesia. So irrigation by diversion works to divert the water through a system of canals and then irrigate the lands. The ruins of Mohenjo-daro and Harappa, Indus Valley civilizations, have also shown the proof of use of water for water supply and irrigation. So you can see that in different parts of the world, this artificial application of water to the agricultural lands, it has been practiced since long time. Now, irrigation engineering consists of 4 phases. The first phase is storage or diversion. So in the first phase, we have to determine that do we have to construct a dam, or we have to divert the water directly through a canal from the river. That is diversion. The second phase is conveyance of irrigation water. So how the water will be conveyed? For this, we have to construct a network of canals that convey the water to the agricultural fields. The third phase includes distribution and application of irrigation water. once we carry the water, let's say for example from a dam through a system of canals, then how this water is distributed among the farmers, and application of irrigation water and how the farmers apply that water to their fields. We will study different methods of water application to the agricultural lands. And the fourth phase is drainage of excess water. When we supply water to the agricultural land at any time, not all of the water that is used by plants for their growth. And this is especially true in case of Pakistan, where we are using very conventional methods of water application to the crops that results in waste of the irrigation water. So the water should not stay on the agricultural land for a long time. After the water is applied to the crops and the crops take the water according to requirements, the remaining water should be drained from that area. Because if the water stays for longer time, it will have negative impacts. So for this purpose, irrigation engineering and drainage engineering, they go side by side. So we have to drain the excess water. And for this, we should provide a network of pipes, surface channels, or subsurface drains that can drain the water from agricultural lands. So that's why this drainage of excess water, this is important phase of irrigation engineering. So in this course, we will discuss all these four phases of irrigation engineering in detail. Now, necessity of irrigation, why we need to artificially supply water to the crops for their growth. The first reason is less rainfall. Since the rainfall that occurs over an area may not be sufficient to meet the full requirements of the crop, so we have to artificially supply the water. So the first reason is that when we have less rainfall, it necessitates irrigation. The second point is non-uniformity of rainfall. When the rainfall occurs, so it's not uniform from one place to another place. So consequently, we have to also supplement the crop water requirements through irrigation. This also means that the rainfall that can occur from time to time is not exactly the same quantity. As I said before, that rainfall is a random variable, sometimes more rainfall, sometimes less rainfall. So this is also non-uniformity. So in this case, we have to artificially supply the water to the crops. Commercial crops with additional water. With irrigation, water, we can grow commercial crops that require additional water. For example, we grow cotton, we grow sugarcane that require more water. So these are commercial crops that we sell and earn the money. So we can grow these commercial crops with additional water. In irrigation, we have controlled water supply. For example, we have a dam, so we can supply the water from the dam through the canal to the agricultural land in a controlled manner. When the water is required, we can supply the water. And how much quantity the water is required, we can supply that quantity of water. Because in case of rainfall, we do not have control. It's a natural process. How much rainfall occurs, in what amount, so we do not have control over that. But in case of artificial application of water, we can have control over the water supply. So that is why we can supply the water to the crops when they required and at one quantity they required. So this can help in optimal yield because we supply the required quantity of water at the required times. Development of agriculture in desert area. So in desert area where crops cannot grow because of less rainfall, so by construction of network of canals, we can bring areas in the desert under cultivation. So these are the different factors that necessitates irrigation. Advantages of irrigation: increase in food production, because we artificially supply the water to the crops at the required intervals in the required quantity. So this basically helps to increase the crop yield. With irrigation, we can bring more areas under cultivation, and this results in increase in food production. We can grow more crops because of irrigation. Cultivation of cash crops. Cash crops, for example, we have cotton that earn cash for us. You see, when we grow the cotton, we do not eat it, but we sell the cotton. So these are known as cash crops. So this is possible with the help of irrigation. Cultivation of cash crops. Generation of hydroelectric power. You can see that when we construct a dam to store the water, that main purpose is to supply water for agriculture, but at the same time we can also generate electricity. So this is the benefit of irrigation. Also, it is possible that we can construct run of a river hydroelectric power project. Just like, for example, I give you the case of Ghazi Barota hydropower project, which is just a channel which runs from Ghazi to Barota, and there a head is available, and we are utilizing that head of water to generate electricity, and the water can flow downstream and can be supplied for agriculture purposes. So this is also an advantage of irrigation. Domestic and industrial water supply. So for irrigation, we built a network of canals that supply water to the agricultural lands, but at the same time, those canals can be used to supply water for domestic and industrial purposes. Because not all the time the water is used by the crops. So at other times, the same water can be supplied for domestic and industrial water supply. Improvement in the groundwater storage. Since we construct a dam to store the water, then seepage can take place and it can improve the groundwater storage. Similarly, the network of canals that we have, for example, in the Indus Basin irrigation system, seepage takes place and this water can recharge the groundwater storage. As we discussed in the first lecture, that groundwater storage, this is important source of water in Pakistan. Especially in Punjab, it is intensively used for agriculture purposes. Improvements of communication. You can see here that when we construct the canals, at the sides of canals, we also commonly provide the roads. You can see here, we also provide the roads. So this results in improvements of communication in that area. So these are the advantages of irrigation. We also have some disadvantages of irrigation. The first thing is raising of water table, that is water logging. Because of irrigation, the water table, it can raise, and if it reaches the root zone or intersects the ground surface, then the land productivity that will be negatively affected, and we cannot grow crops on that land. This is known as water logging. So because of this irrigation, as I give you example last time of the Tarbela Dam, that when we constructed the Tarbela Dam, the seepage from the reservoir raised the water table in the adjoining areas, and it caused this water logging in the surrounding areas. So this is a disadvantage of irrigation. Because of irrigation, the water is supplied to the agricultural fields, so it can produce a damp climate, which is undesirable. And because of the water that stays over the land, it can become breeding place for mosquitoes, and it can result in spread of diseases. So these are a few disadvantages of irrigation. Now, other issues that are associated with irrigation, the first one is competition for surface water rights. It means that the water we are using for irrigation may not be available for domestic and industrial water supply. So this can result in competition for surface water rights. The water which we use for domestic purposes, for industrial purposes, may not be available for agriculture purpose. So you can see that there is a competition between these different fields for use of water. The second issue is depletion of underground aquifers. As we discussed in the previous lecture, that in Punjab, the groundwater is pumped and is used for irrigation purposes. So if the recharge of the groundwater is less than the discharge of the groundwater, then this can result in depletion of underground aquifers. So these underground aquifers provide important source of water. So because we are using extensively the water for agriculture purposes, this can result depletion of underground aquifers. Built up of toxic salts on soil surface in areas of high evaporation. Now the irrigation water, when it moves on the surface of the land, so the soil contains different salts, and these salts are dissolved in the water. And if in an areas we have very high evaporation, the water will quickly evaporate and leaving these salts behind on the soil surface, which are not beneficial for the crops. Over irrigation, because of poor distribution, uniformity, or management of wastewater, chemicals, and it may lead to water pollution. If we supply more water, what will happen? Because on the, agricultural land we apply the fertilizers and pesticides, so these are mixed with water and then they are taken up by the crops. But if we have over irrigation, means more water is supplied, then the same water, if it drains into a natural stream, then definitely it will cause water pollution. The same water cannot be used for other purposes downstream, or the water can infiltrate into the soil and then through percolation the water can join the groundwater storage and can cause water pollution. So the groundwater that can be used for domestic purposes, for drinking purposes, will contain these chemicals. So it will become a health hazard. So these are the potential problems that we face due to irrigation. Next, we have aerial distribution of rainfall in Pakistan. You can see here arid zone where average annual rainfall is 10 inches. So it covers the arid zone, it covers 67% of the land of Pakistan. And another 24% of the land of Pakistan that is classified as semi-arid, where the average annual rainfall varies from 10 to 20 inches. So you can see here that about 91% of the land of Pakistan that is classified from semi-arid to arid land. So you can see here that why we need irrigation. And this is the reason why Pakistan has the largest continuous surface irrigation system in the world. Because you can see that 91% of the area of Pakistan that is semi-arid to arid. 5.5% that is humid, 20 to 30 inches average annual rainfall, and 3.5% average annual rainfall is 30 inches. So you can see the scope of irrigation in Pakistan and irrigation engineering. That is why we have irrigation department in every province, and in KPK we have Minister for Irrigation. Next we discuss the Indus River Basin, because we will discuss about the Indus Basin irrigation system. So you can see here the portion that is shown by the solid red line. This is actually the Indus River Basin. And this Indus River Basin is spread over 4 countries. You can see here Afghanistan, we have China here, we have India here, and we have Pakistan. You can see that this Indus River actually originates in China. Then it flows through the territory of India and it enters into Pakistan. The other rivers in the northern area, such as the Gilgit River, joins the Indus River. The Kabul River here, the Swat River here joins the Indus. You see we have the Indus River here. Now the other tributaries such as the Jhelum River and the Chenab River, you see they also originate in India. They join together with Ravi River. We have the Beas River, it joins the Sutlej River, and then the Sutlej River, the Ravi and others, they join here again the Indus. So you see that Indus River and its tributaries. And finally, the Indus River drains into the Arabian Sea here. So that is why this is known as the Indus River Basin. Just like you studied in your hydrology course, it means that within this red boundary, anywhere if there is rainfall, anywhere, it will contribute the water to the outlet here. Ultimately, it will contribute the water to the outlet here. So consequently, this whole area, this is a basin. It means that if a rainfall is occurring here, it will contribute water to another outlet. So this is the basic concept of the basin. So you can see that the Indus Basin, it spreads over the 4 countries. But the greater portion that lies in Pakistan. Now the hydraulic structures in the Indus Basin irrigation system, you can see here that we have the western rivers, the Indus River, the Jhelum River, and the Chenab River. We discussed the Indus Water Treaty. Pakistan has full control over the water use of these 3 western rivers, whereas India has full control over the use of water for these 3 eastern rivers, Ravi, Beas, Sutlej. This red dash line basically shows the partition line. So now on the Pakistan side, you can see that on the Indus River, we have the Tarbela Dam, Kalabagh Barrage, Chashma Barrage, Tonsa Barrage. On the Jhelum River, we have Mangla Dam, Rasool Barrage. On the Chenab River, we have Marala Barrage, Kadirabad Barrage, and then downstream we have the Trimu Barrage. The Ravi that enters into Pakistan, we have Balochi Barrage. The Beas joins the Sutlej River, and the Sutlej River enters Pakistan. We have Suleiman Ki Barrage, Islam Barrage. Then here we have Sidnai Barrage. Then we have Panjnath Barrage, and we have the Gaddu Barrage. So these are the different hydraulic structures in the Indus Basin irrigation system. Indus Basin irrigation system that we have in Pakistan, you can see here the rivers, Indus River and its tributaries. So in this figure, you can see that how we have developed agriculture along the banks of these rivers, and the areas you can see between the rivers. You can see here that this area in KPK here, this is the northwest mixed cropping. Different types of crops are grown here. Similarly, here you can see that this yellow color, this is Punjab mixed cropping. The light green color which you can see here, that is Punjab sugarcane wheat. This light blue color, at this point here, you see the light blue color. This is Punjab rice, wheat. Then the dark green color you can see here, that is Punjab cotton, wheat. The purple color which you can see in Sindh, that is the Sindh cotton, wheat. And the dark yellow or brownish color you can see Sindh rice, wheat. You can study this paper in detail. Now this is how, because of the Indus Basin irrigation system, we have this agriculture, that we supply the water from these rivers. This is the land use in Pakistan. You can see here the shaded green portion. This is area under irrigation. The combination of white and blue color is area that can be brought under irrigation. You can see here this area can be additionally brought under irrigation. So we can increase the food production. Pakistan can become self-sufficient in food, and we can export and earn the foreign exchange. So the geographical area, that is 196 million acres. Now area suitable for agriculture, that is 77.1 million acres. That is suitable. Cultivated area, that is irrigated plus the rain-fed Barani, that is 54.5 million acres. Now area under irrigation by all sources, that is 44.5 million acres. Additional area that can be brought under irrigation, irrigated agriculture, that is 22.6 million acres. This area can be additionally brought under irrigated agriculture. So you can get the idea from here that irrigation engineering has a big scope in Pakistan. Pakistan has the potential to bring additional areas under agriculture. And since agriculture is the backbone of our economy, Pakistan is an agricultural country. It can create jobs for people. Next, we discuss the Indus Basin irrigation system. The Pakistan's Indus Basin irrigation system is the largest contiguous gravity flow irrigation system that serves the Indus River and its tributaries, namely Jhelum, Chenab, Ravi, and Sutlej rivers. So the Indus Basin irrigation system that we have in Pakistan, that is the largest continuous surface water irrigation system in the world. It consists of 3 major storage reservoirs, 19 barrages, 2 headworks, 2 siphons across major rivers, 12 link canals. When we supply water from one river to another river, that is done by construction of a canal that is known as link canal. 44 independent canal commands, means that these canals supply independently water to the areas, different areas. 44 independent canal commands, 23 in Punjab, 14 in Sindh, 5 in KPK, and 2 in Balochistan. And more than 107,000 main water courses commanding an irrigated area of 16 million hectares. 1 hectare is equal to 10 power 4 square meter. 16 million hectares. The aggregate length of the canals is about 56,073 kilometers. The total canals that we have, if you add up their length, so that is about 56,073 kilometers. In addition, the water courses, farm channels, and field ditches, the narrow channels that supply water to the farmers, are estimated cover a length of about 1.6 million kilometers. The irrigation system of Pakistan further utilizes over 41.6 million acre feet of groundwater pumped through more than 700,000 public and private tube wells. So in addition to the surface water that we are using, the Indus River and its tributary, the irrigation system of Pakistan additionally utilizes over 41.6 million acre feet of groundwater. So that is pumped through more than 700,000 public and private tube wells. It means that we are supplementing the canal water with the groundwater. The total geographical area of Pakistan is 709 million hectares. Out of this, only 34 million hectare area is suitable for agricultural production, while only 20.1 million hectare area is practically cultivated. You can see here the potential of irrigation engineering that will serve to develop the additional area that can be cultivated. The irrigated area in all the 4 provinces is estimated as 16 million hectares. The remaining cultivated area is rain-fed. So some areas we are totally dependent on the rain for the growth of crops. The Indus Basin river system makes a prime source of water for Pakistan's agriculture, which provides for an income source to about 75% of the country's population. So you can see that about 75% of population of Pakistan that is linked with the agriculture and contributes about 25% to the GDP, gross domestic product of the country. So the contribution to the GDP of Pakistan, that is 25%. It engages about 45% of the country's labor force and provides a sound base for the economy in terms of export and foreign exchange earnings. So this is very important because you see that the cotton that we grow, so these all play important role in terms of export and earning foreign exchange. So all these figures that I present here and in here, so these are taken from this book Applied Irrigation Engineering that is published from University of Agriculture, Faisalabad in 2017. Next we discuss the water budget of Pakistan. This is the figure that is taken from the book by Dr. Iqbal Ali, Irrigation and Hydraulic Structures, Theory, Design and Practice. So this is a water budget of Pakistan. You can see here that river Indus, it supplies the water of around 90 million acre feet. The river Jhelum, around 21 million acre feet. River Chenab, 22 million acre feet, and other tributaries, they are contributing 4.5 million acre feet, making a total of 137.5 million acre feet. That is the surface water available annually. Now, out of this water, it is distributed between the Kharif season and between the Rabi season. The Rabi season is the winter season and the Kharif season is the summer season. Now you can see that out of this 137.5 million acre feet, 32 million acre feet of water that is drained to the or discharged to the Arabian Sea. If we have more storages, we can store this water, and with this additional water we can bring more area under cultivation and we can increase our food production. You can see here. Now for the Rabi season here, plus we have the storages in the Kharif. So 64 million acre feet is Kharif canal flow. This is during the Kharif season. The summer season, the canal flow is 64. And 15 million acre feet we are storing in the dams. As we discussed in the first lecture, during Kharif season, more water is available. And the main reason is because of high temperature. The glaciers, they melt at high rate. So we store that water. And then the same water can be released during the Rabi season. So you can see that then during the Rabi season, 34 million acre feet water is available in the canal. Actually, the river flows contribute only 22 million acre feet. But because we store the water during the Kharif season, we release it during the Rabi season to meet the crop water requirements. Now this water flows in the irrigation canal network during both the seasons. So we have the losses. We have the evaporation losses that you can see here. So the water that is evaporated directly from the rivers, that is estimated as 4.5 million acre feet. That is the evaporation of water takes place from the surface of the rivers. From the canals, the water that evaporates that is estimated as 7.5 million acre feet. Then from the canals, the water flows into water courses. We are distributing the water. So from there, the evaporation is 7 million acre feet. At the same time, from these canal network, we have seepage, the water that infiltrates into the soil and that ultimately joins the groundwater reservoir. So from the river and from the rains, it is estimated that 7.1 million acre feet of water recharges the groundwater reservoir from river and rains. From irrigation canals, you can see the seepage, 15.3 million acre feet. So actually there are two aspects now. For example, if we study about the lining of canals, then what will happen? It will prevent this seepage and the surface water will increase, more water will be available to the crops. But on the other side, then these water from the canals, they recharge the groundwater. We will stop the recharge of the groundwater, which is also important source for domestic, industrial and agriculture purposes. From the link canals that link the two rivers, the seepage is estimated at 3 million acre feet. And from the water courses, another 7.5 million acre feet. From the groundwater, we are also supplementing the canal water irrigation system. So it says that 38.1 million acre feet of water through tube well, that is discharged, well contribution. And then it flows in the system. So there is again evaporation, well water, that is 5.6 million acre feet evaporation. So now you can see that during Rabi flow, the fields, the agriculture fields, they get 22.4 million acre feet during Rabi season. During Kharif season, 38.4 million acre feet, and from the groundwater, 32.5 million acre feet. We also have rainfall that directly supply water to the crops, that is estimated as 6 million acre feet. And because not all of the water is used by the crops, as we discussed that in Pakistan we are using very conventional methods of water application that we will discuss in today's lecture. So the runoff that is drained from the field, that is estimated at 6 million acre feet. So this is the water budget of Pakistan. Now this is taken from another source, water budget of the Indus Basin irrigation system. Mean annual river flows vary from 140 to 150 million acre feet. The mean annual canal diversions, that is 103 million acre feet. This is the water that is diverted through the canals. Canal supplies at water courses had 77 million acre feet. Why? Because we discussed the evaporation and the seepage losses. Canal supplies at the farm gate that is available to the farmers, that is 54 million acre feet. And the groundwater contribution, that is 50 million acre feet. So irrigation water at the farm gate, that is 54 plus 50, this is 104 million acre feet. So this is just a guideline values to let us know that how much the water is reaching actually to the farm gate. Next we have this water budget of the Punjab irrigation system. So you can see here that Punjab's share in water accord 1991, that is around 56 million acre feet. So canal diversions, that is 50 million acre feet. We have losses in the canals, that is 13 million acre feet. So water availability at the outlets that they call it as MOGA in Punjab. So that is 37 million acre feet. And losses in the water courses, that is 11 million acre feet. Now the water that is available at the farm gate is actually 26 million acre feet. You can compare here the share, and then you can see here that the water available at the farm gate. Then we have the groundwater abstractions, that is 33 million acre feet. So you can see here that in Punjab, how much they are using the groundwater to supplement the canal water. So the total available at field, that is 59 million acre feet, but then we have field losses. So the net available at the field level, that is 38 million acre feet. So available for the crop use, that is 45 million acre feet. And what we have, the actual crop water requirements, that is 65 million acre feet. And this also includes the water availability from the rainfall, that is 7 million acre feet. So you can see the gap between the water available and the water required by the crops. So how can we make the agriculture system sustainable if we have this situation? This is the reason why that Pakistan has the largest continuous irrigation system in the world, but the crop yield that is lowest in the world. And there are many reasons for that we will discuss.